Hello friends, part 2 of your podcast on section 4.4 in the Algebra 2 book. We just left off talking about difference of squares, and now we're going to talk about perfect square trinomials. Again, in perfect square trinomials, the first, in other words, the A term and the C term, both need to be perfect squares, and in this case they are. And the sign of the C term has to be positive. All right, and the third thing that makes a perfect square trinomial is that the middle term will be 2 times the square root of the first times the square root of the second. So you can see here 2 times 3y times 7 is going to give me 42y. This sign can be negative or positive, and that's why you have 2 different examples here. So it's one more thing to think of, but I will write these general forms on the board in the classroom. But you need to remember what they are. Okay, we got difference of squares and we got perfect square trinomial. For some people, it may be easier to remember it like this. All right, if I have anything plus anything else and I square it, what I'm going to get is this first term. So the square squared, and then plus 2 times the square times the triangle. So that is whatever the square and the triangle are for numbers, and then the triangle squared. And if I have a negative sign, all right, I'm going to get the square squared minus 2 times the square times the triangle plus the triangle squared. So I can just substitute in whatever numbers I have. So if you look in this example right here, the square is a 3y and the triangle is a 7. So when I plug this in, you can see that what I get. Now, this may not be the most easy way for any of you to remember this, but for some people I think it might be helpful. I'm just doing it to point out the pattern. If I was to do the pattern up here with the difference of squares, so if I have something squared minus something else squared, that breaks into the first plus the second times the first minus the second. It's just a different way to think about it that may be helpful for some people. For most of you, I suspect it's going to be easier to just look at an example. So when I look at these, now clearly at the beginning, I'm pointing out to you that this one right here is going to be a perfect square trinomial. And I know that because 16y squared is a perfect square, and its square root is 4y, and positive 25 is a perfect square. That's 5. So in this case, this would be my square, and this would be my triangle. And the only thing that's really that I've got to concern myself with is this sign right here. So according to our pattern, if I have a perfect square trinomial, it's going to be the first, which is 4y, this sign, and the 5 all squared. That's the answer. So, boy, that was easy, right? Compared to the other factoring we've done, much easier. What's the hard thing? I have to remember the pattern and I have to look for it. But once I recognize the pattern, once I recognize that this is a perfect square trinomial, then business is pretty easy. On this one, I'm recognizing that this is a difference of squares. First giveaway is that the whole thing just has 2 terms, okay? And this one is a perfect square. Its square root is 2x. This is a minus sign, and this is a perfect square. Its square is 9. So I know all this. So according to my pattern, it's the square root of the first, plus the square root of the second. My bad. Square root of the first plus the square root of the second. Then the square root of the first minus the square root of the second. And I'm done. So again, the hard thing is I've got a pattern to remember, but once I recognize the pattern, it's pretty easy. And again, those general forms will be up on the board. Last thing I want to hit on in these podcasts for 4.4 is that sometimes I need to factor out a term from everything before I go. So in this case, you can see I can take a 4 out of both of these terms. In this example, I can take a negative 3 out of both of these terms. In this example, I can take a negative 2 out of all of these terms. And the reason I do that is that it simplifies what's left to factor. All right, so we're going to hit more examples of this, but if you can, take a look at these problems, try to work them out on your own, and we'll cover them again in class. That's it. Have a good night.